Hey there, this is Andrew, and welcome to the unit test walkthrough. Today we're gonna go over the Algebraic Skills unit test. The link to the test can be found in the description. So, this test is a bit different from the rest of the tests that you will see on the website, as each of the standards will be created as a pass or achieved, or fail or not achieved. There is no excellence for the standards. However, similar to the rest of a unit test, each unit test contains several standards, usually from 3 to 4. This is a massive one. And you will need to master each of the unit tests to get a passing grade. This unit test, I decided to do this video right now as the DP1 will start their IB journey soon-ish, and some of you might have already embarked on this challenging but hopefully rewarding journey in AAHL and ASL. So, without any further ado, let's get started. Standard 1, Basic Number Skills. Just a reminder, you may not use a calculator on any of the standards. So keep that in mind. Going back to standard 1 on number skills. The reason why I decided to make an entire standard on this is because arithmetic is the reason why a lot of students go from a 7 to a 6 or a 4 to a 3. Question 1. Work out 6.5 times 3.1. You can do log multiplication, that works, or you can just split up into two parts. 6.5 times 3, that's 19.5. 6.5 times 0.1, that is 0.65. And you shall get 20.15. Question 2. Evaluate this. Keeping your answer as a mixed fraction. Okay, so 3 and 2/3, that is 11 by 3. 1 and a quarter, that is 5 by 4. The common denominator of 3 and 4, the lowest common denominator is 12. 11 times 4, 44. 5 times 3, 15. 29 divided by 12. You get 2 point something. 2 is 24 by 12. 29 minus 24, that's 5. Therefore, 29 by 12 is 2, 5 by 12. Question 3. 23 plus negative 18 minus negative 5 plus negative 2019 to the power of 0. Let's do the stuff inside the absolute value sign first. 23 minus 18, that is 5. Absolute value of negative 5, that's 5. Negative 2019 to the 0. Negative anything to the 0, except 0, is 1. So negative 2019 to the 0 is equal to 1. 5 minus 5 plus 1 equals to 1. Question 4. 202.5 times 3.75 minus 25 plus 2.025 times 5 to the 4. 202.5 and 2.025, they have something in common. So why don't we write the first guy as 2.025 times 100 times 3.75. 5 to the 4, that's 625. And now we can factor out the 2.025. What's left is 100 times 3.75 plus 625. So 2.025 times 375 plus 625. Don't forget the minus 25 up here. And you get this guy times 1,000 minus 25, or 2,000. That's the final answer. Question 5. You're given that 7a is equal to 6b, and 4a minus 3c divided by 2b minus c is equal to 9. Let's start off with the second equation, and we'll see if we can simplify this. So 4a minus 3c is equal to 18b minus 9c. Or 6c is equal to 18b minus 4a. We know that 6b is equal to 7a, so 18b is 3 loads of 6b. I'm just going to do it one step at a time. 6b, we can now replace it with 7a. Therefore, a is equal to 6c divided by 17, and b is equal to 7 by 6 times a, or 7c by 17. Thus, if c is 17 parts, a would be 6 parts, and b would be 7 parts. Part B. You now want to find 5a plus 8b divided by 7b plus 3c. So 5a, let's say a is equal to 6. If a is equal to 6, then b is equal to 7. If b is equal to 7, then c is equal to, that should be a 7. Then c should be equal to 17. 5 times 6, 8 times 7, 7 times 7, 3 times 17. 86 over 100, or 43 divided by 50. We can do this because we're looking for a ratio. So we can assume a equal to 6, b equals to 7, c is equal to 17. Moving on to question 6. 321 minus 4 times 2 squared times 25 minus 5 times 2 cubed divided by 11 minus 8 cubed. One step at a time. Remember your order of operations. We'll start with what's inside the brackets first. 321 is not a priority. 4 is not a priority. Now we'll focus on this round brackets. 2 squared, that's 4. 2 cubed, that's 8. So 321 minus 4 times 4 times 25, 5 times 8, 11 minus 8, cubed. 321 minus 4 times 60 divided by 3 cubed. 321 minus 240 divided by 27. So we get 81 divided by 27, or 3. Question 7. Absolute value of negative 12 plus 48 times 37 plus 36 times the absolute value of negative 24 plus negative 39. 48 minus 12, that is 36. Negative 24 plus negative 39, that would be negative 63. Absolute value of a positive number, absolute value of a negative number will return the positive value. We can now factor the 36 out. And we're at 3600. Question 8. Finally, 0.4 minus 2 by 5, x plus 0.75 is equal to 15%. So, there's a lot going on here. 15%, that is 0.15. We can also expand this bracket. Negative 2 by 5 times x, negative 2 by 5 times 0.75. Okay. I'm gonna move everything to this side. Negative 0.05 is 2 divided by 5x. So x should be negative 0.125. Once again, you need to be able to do basic arithmetic quickly and correctly. If your skills are not there yet, that is totally fine. But it should be your priority to get it up to scratch before IB hits. Moving on to standard 2, expansion and simplification. You should be able to do all of these questions relatively quickly. By that I mean finishing the entire 4 questions in about 10 to 15 minutes. If you're unable to do that, you need to brush up on this ASAP. This is even more important than the fractions and decimals that you just did in the previous standard. So, question 1. Expand 2x plus 3, 3x minus 1, x squared plus 4. You can use any method you want. You can use the grid method, or you can just expand terms one by one. So, let's multiply the first 2 terms. 2x times 3x. 2x times negative 1. 3 times 3x. 3 times negative 1. I'm gonna simplify this. Moving on. 6x squared times x squared. 6x squared times 4. And so on. And so forth. Simplifying this, we only have one term in x to the 4, one term in x cubed, two terms in x squared, one term in x, and one term in x to the 0, or one constant term. And that's question 1. Question 2. We would like to simplify this. Look at the first 2 terms. There is a shortcut to this. We have a difference of squares. In this case, a is x cubed and b is 3. Therefore, the first 2 terms can be simplified like this. The next 2 terms, you should also be able to recognize this product. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. A is x squared, b is 3. Notice that there's a negative sign here, and the coefficient of ab is 1. It is not a squared minus 2ab plus b squared. It is not this guy for the middle term. So a cube plus b cube. So we have x to the 6 minus 9 times x to the 6 plus 9. Oh, sorry, plus 27. And therefore, we have x to the 12 plus 18, x to the 6 minus 9 times 27. That is 243. Question 3. X plus 1 cube minus 2x plus 3 times 3x squared minus 2x minus 5. X plus 1 cube. So, you will see this again when we talk about binomial theorem. But a plus b cubed, that is a cubed plus 3a squared times b plus 3ab squared plus b cubed. This is a shortcut that everyone should know. In this case, a is equal to x, b is equal to 1, so this is very convenient. X cubed plus 3x squared plus 3x plus 1 minus, this is where you have to be very careful. You are subtracting the entire product here. Let's do it term by term. 2x times 3x squared. 2x times negative 2x. 2x times negative 5. 3 times 3x squared. 3 times negative 2x. 3 times negative 5. 3x squared. 3x plus 1 minus 6x cubed. Did I forget any squared terms? This one should be squared as well. Negative 4x squared plus 9x squared. This guy should be 10x. Negative 10x minus 6x. And then minus 15. One, two, three, four. 1, 2, 3, 4. Be efficient without losing accuracy. Question 4. You are given an identity. This multiplied by that gives you x to the 4 minus x cubed plus cx squared plus dx plus 12. This is very similar to a technique that you will see in IB. Of course, you can expand and equate the left and the right hand side. That is totally valid. I would rather use a different method. First, let's look at the constant here. 12. How can we get the constant term from the expansion? The constant from here and the constant from there. Therefore, negative a times negative 4 is equal to 12, or a is equal to 3. One part, done. Moving up to the x term. How can we get the x term from the expansion of the left-hand side? There are two ways, right? We can take this constant term times bx times negative bx, or the 2x times negative 4. 2 times 4, negative 4, plus negative a times negative b. That is not very useful, but let's see what we get from here. Negative 8 plus 3b is equal to d. We can also look at the x cubed term. The coefficient of the term in x to the 3 is -1. We can get the x cubed term from x squared and bx, or from 2x and x squared. So 1 times -b plus -a times, plus 2 times 1 is equal to -1. B plus 2 is equal to -1. B is equal to 3. If B is equal to 3, then we know D has to be equal to 1. Last but not least, let's find C, x squared. If we look at the coefficient of the x squared term, how many ways can we get it? We have -a times x. We have 2x times -bx. And we also have -2 times -4. So 1 times -4, 2 times -b, -a times 1. And that is equal to c. -4, 2 times -b, b is 3, so -6. -a times 1, a is 3, so -3. So c is therefore -13. Therefore, a is equal to 3, b is equal to 3, c is -13, d is equal to 1. That is the end of Standard 2. Standard 3 is on factorization and algebraic fractions. So for factorization, you should know the difference of squares. You should also know that a squared minus 2ab, plus 2ab plus b squared is equal to a plus b squared. And a squared minus 2ab plus b squared is equal to a minus b squared. Question 1. We would like to factorize 2a to the 4 times b minus a cubed b cubed. So first off, we're going to look for the common factor, a cubed and b. Why? The greatest common factor of a to the 4 and a cubed is a cubed. The greatest common factor of b and b cubed is b. The greatest common factor of 2 and 1 is 1. Therefore, we can factor the 1 a cubed b out of the bracket. What's left is 2 times a minus b squared. Can we do anything else with it? No, we cannot. So that's the end of our factorization. Question 2. 9t to the 7 minus 4t cubed. Let's start off by factoring out the common factor. The greatest common divisor, the greatest common factor of 9 and 4 is 1. The greatest common factor of t to the 7 and t cubed is t cubed. So we can factor t cubed out of the bracket. What's left is 9t to the 4 minus 4. Now we have a difference of squares. So we're going to get to 3t squared minus 2 times 3t squared plus 2. You can choose to factorize this term further. That's totally up to you, but it's optional. The reason is simply because it's not as pretty, so I prefer to keep it like this. Question 3. X to the 4 minus x squared minus 12. We know that this is a hidden quadratic, and we are going to split this term in the middle so that we can group the two terms together. We need to find two numbers that multiply to -12 and that add up to -1. So we can use -4 and 3. factor the x squared out, factor the 3 out. We notice that they have this in common. Voila. We're not done yet. Now I would like to factorize this because this is nothing more than a difference of squares. And that's the end of the question. Question 4. X cubed plus x squared plus 4x plus 4. Okay, so we can just factor the x squared out from this. And we can factor the 4 out from there. So we get to x squared plus 4 times x plus 1. Done. Easy peasy. 5. This is where things get more interesting. When we look at this expression, we notice that they have this part in common, the a squared plus 5. So, if you can handle this straight away, that's good. If not, I would recommend using a dummy variable. A dummy variable is simply a shorthand. It doesn't really do anything to the equation, except making it look a bit less intimidating. So if t is a squared plus 5a, this guy now becomes this. And now we just have to factorize this expression. Easy peasy. Substitute t with a squared plus 5a. Realizing that you can factorize this even further. And you can also factorize that even further. And that is the end of question 5. For questions 6 to 8, you are asked to simplify algebraic fractions. 6. 3x squared minus 6x divided by x to the 4 minus 16 divided by 1 over x squared plus 4. So, when dividing algebraic fractions, the first thing you gotta do is to factorize all the numerators and the denominators where possible. For the top left numerator, for the numerator of the first fraction, if we factor out the 3x, we are left with x minus 2. Downstairs, we have x squared minus 4 times x plus 4, x squared plus 4. Since we're dividing, we can flip the numerator. We can flip the denominator and the numerator. Those two cancel out conveniently. And what we're left is 3x times x minus 2 divided by x squared minus 4. This is a difference of squares. So we are down to this as our final answer. That cannot be reduced further. Question 7. And x squared minus 18x plus 8. 10. Looking at the numerator, we can factor out the x minus 1 squared. From the first term, we're left with 4 times x minus 1. For the second term, we're left with x. In the denominator, we can factor out the 2, and you're left with 5x squared minus 9x plus 4. 4 times x minus 1 plus x, that's 5x minus 4. Downstairs, 5x squared minus 9x plus 4, that would be 5x plus 4 times x minus 1. No, it's 5x minus 4 times x minus 1. Simplify, simplify, and you're down to x minus 1 divided by 2. Question 8. 2x squared plus 3x divided by 2x plus 3, x minus 2, minus 6 divided by this guy. Let's try to simplify if we can. The first term, let's factor the x out. Conveniently, we also have 2x plus 3 as a factor in the denominator. For the second term, we can factorize the denominator. And now we are ready to add the two fractions. The common denominator here is going to be x minus 2 times x plus 1. So to add the two fractions, you got to multiply x plus 1 to the first term and do nothing to the second term. Bang. Factorizing the numerator, you will get x plus 3 times x minus 2. Cancel out, and your final answer is x plus 3 divided by x plus 1. Easy peasy. Standard 4. Surds, fractional indices, and negative indices. Question 1. Root of 18 minus root 2 plus root of 72. Root of 18, that is root of 9 times 2. Root of 72, that's root of 36 times 2. Root of a times b, that's root a times root b. On the exam, of course, you don't have to write this intermediate line. You can just jump straight to the next one, and you shall get 8 root 2 as your final answer. Question 2. 4p in bracket squared divided by square root of 4p to the 5. 4p in the bracket squared, that will be 4 squared times p squared. The square root of a times b, that's the square root of a times the square root of b. 4 squared, that is 16. Square root of 4, that's 2. Square root of p to the 5, that's p to the 5 divided by 2. So you would get 8p to the negative 1 by 2. But we are asked to give our answer with positive indices. We have to rewrite this as 8 divided by p to the 1/2. Alternatively, 8 divided by the square root of p. Question 3. X squared minus x to the 3 by 2, x minus x to the 1 by 2. Okay, so let's multiply. X squared times x. X squared times x to the negative 1 by 2. X to the 3 by 2 times x. X to the 3 by 2 times x to the 1/2. Simplify the middle term, and you're done. Question 4. This question asks you to rationalize the denominator. This skill is usually assessed at least once on the official exams that you will write at the end of DP2. So this is important. To rationalize the denominator for the first term, we are going to multiply by the conjugate. The conjugate of root 5 minus 2 is root 5 plus 2. And we are going to multiply this factor to both the denominator and the numerator. The reason for this is because we will have a difference of squares in the denominator. The denominator here is 1, so we can ignore it. Look at the first term, 1 plus root 5 times root 5 plus 2. So, root 5 plus 2 plus 5 plus 2 root 5. Similarly, for the remaining two terms, 3 plus 2 root 5 minus 3 root 5 minus 10. I got 10 because it is 2 times root 5 times root 5. And root 5 times root 5, that is 5. Minus 2 root 5, plus 2 root 5, sorry. And the constant, 0. So your final answer is 2 root 5. Question 5. This is the hardest question in the standard. For the first term, you can choose to rationalize the denominator. However, there is an alternative. In this case, let's see what happens if we factor the root 3 out of the brackets. We can cancel out. The second term, we have the square root of a squared number. This will return the absolute value of a. Since 3 is larger than root 3 is around 1.7 something, give or take. This guy now becomes 3 minus root 3. And again, we have a difference of squares. So 6 is our final answer. That is the end of standard 4.